Students, today our topic is going to be about ripple tank. First of all, we discuss the definition. Ripple tank is a device to produce water waves and to study their characteristics. And now we'll study how to construct it. This apparatus consists of a rectangular tray having glass bottom and is placed near half meter above the surface of the table, like shown in the diagram. Here's the bulb and here is the table. You can see the water on the surface, and the reflection or the light basically bounces off the water waves and is being shadowed over here. So this is the ripple tank. Wave can be produced on the surface of water present in the tray by means of a vibrating pedal. This vibrator is an oscillating electric motor fixed on a wooden plate over the tray such that its lower surface touches the surface of the water. Let's make it. Here we go. So here is the motor and it is basically placed on the wooden plate. Now this plate is basically touching the surface of the water, and when it vibrates it produces waves which can be seen underneath over here. Let's label it. So here we can see illumination by the bulb. Is a shallow tank of water, oscillating pedal which is over here, and power supply which is giving the motor some power. How does it work? On setting the vibrator on, this wooden plate start vibrating to generate water waves consisting of straight wave front diagram. An electric bulb is hung over the tray to observe the image of water on the paper or screen. You can see very clearly the light will come over here like this, and basically pass through over here like this, and we can see the shadow right over here. The crest and trough of the wave appears as bright and dark fringes, especially on the screen. Now we explain the reflection of water wave with the help of ripple tank. You can see the waves, basically some are dark, some are light, which can be seen clearly. Now we can clear it out. If we want to see from the top, we can see that there are dark and bright fringes right over here, and the distance between two dark or light fringes is 1 lambda. So as the vibrator moves, the wave basically moves like this. Place a barrier in the ripple tank. The water wave will reflect from the barrier like so. So if this is the barrier and wave will hit the barrier like this, if the barrier is placed at an angle to a wave front, the refractive wave can be seen to obey the laws of reflection, which is the angle of the incident wave along the normal will be equal to the reflected wave like this. So as the light will come or wave will come, it hits the barrier and basically reflects back like this. So we can see it actually happening, hitting the barrier and going back. Let's see it again. You can see it very clearly now. It's making an angle and it's obeying the law of reflection. So reflection says, thus we define the reflection of wave as when the wave moves in one medium falls on the surface of the other medium, they bounce back into the same medium such that an angle of incidence equal to the angle of reflection. The speed of the wave in water depends on depth of the water as well. So you can see where there is shallow water, the speed is slow. Where there is deep water, the speed is faster. If a block is submerged in the ripple tank, depth of water in the tank will be shallow, over the block and then elsewhere. Like, let me show you in form of a diagram. That means on the side view of this ripple tank, if we place a block over here, the water surface over here will be on the same level, but the depth over here will be more and the depth over here will be less. So when water moves from here to here, basically its velocity will basically change. Let's see what happens because of this. When water enters the region of shallow water, their wavelength decreases. So as it enters into the shallow water, its wavelength decreases, and because of this, basically it bends right at the boundary. But the frequency of the water wave remains the same in both the path of the water because it is equal to the frequency of the vibrator. Which vibrator? If you remember, we basically made this one. This is the vibrator we are talking about. So as the wave was moving from a denser medium, or we can say more water into a shallow water, it bends. You can see very clearly over here. So this is the point. Because of bending, the light bends. We can say now that the wave basically bends as well when it moves from one portion to another one. So this is known as reflection. This change of path of water wave while passing from a region of deep water to that of a shallow one is called reflection, which is defined as when a wave from one medium enters into another second medium at the same angle, its direction travel changes. So this is why we are calling it reflection. Now we observe the phenomenon of diffraction of water. Let's say there is a barrier in the ripple tank and generate a straight wave in a ripple tank that places two obstacles, which is one over here and one over here, in a line such a way that the separation between them is equal to the wavelength of the wave. That means this separation is equal to the wavelength of the wave. Now let's say that this is the wave we are talking about and it's moving right at this point, right over here, like this. So what will happen now? In this case, we'll see the wave basically produces a small semicircular part over here, then grows and grows and grows and grows and grows like this. After passing through the smaller slit between the two obstacles, the wave is spread in every direction and changes into small semicircular pattern like over here. So the wave basically, if the wavelength is bigger than the slit, then the wave basically diverges, or basically you can say spreads in every direction in a semicircular manner right over here. Reflection of wave can only be observed clearly if the size of the object is comparable with the wavelength of the wave. That means if this region is very large like this, that means if the wave is coming and the passage is very large, then the wave won't bend or spread like this. Figure shows the deflection of wave while passing through the slit with size larger than the wavelength of the wave. Only a small deflection occurs near the corners that we can see over here. Small deflection occurs, but most of the wave passes through easily. This phenomenon is known as diffraction. The bending or spreading of wave around a sharp edge or corners of an obstacle or slit is called diffraction. So we have studied from this whole article that there are three characteristics of wave: reflection, refraction, and diffraction. Thank you very much for your time.